Okay, so plan for today, I'm going to switch from Waker to Python implementation. So therefore, we'll start with one of the problems we have handled earlier, which is the iris dataset. So let me open up the dataset first. You can also follow with me. Then we'll go to program files. Then we'll switch to Waker. Under the data, we have data sets. And what I'm going to select is the iris dataset. Right. And remember last time when we discussed about the zoo dataset, I also explained how you can convert your CSV files into ARF format. So it's a special format used in Wake-up. So iris dataset, if I go with the dataset itself, we have 4 measurements of flowers: sepal length, sepal width, petal length, and petal width. And then there are 3 classes. So there are 3 classes: iris setosa is 1, iris versicolor the second one, iris virginica, this is the third one. It's about classifying 3 different flowers. So you can see how the measurement varies. And if you look at the classes, you can see totally we have 150 instances from each category. So you can see each flower, we have 50 data points. Right. Now, this part is very familiar to you. And I told you like how each of these columns could be used to separate the data. We discussed these ideas earlier. But let me quickly go to classification tab and then choose the classifier. Right. So when we are going to do this, so I'm going to select under the trees, and then it's a numerical data set. So we have to go with J48, which is what we call the C4.5 decision tree algorithm. So I'm going to select that. And then you can decide which test option you are going to go with. I'm going to select the 10-fold cross-validation, click start, and then, I will get the tree structure. And I hope you remember when you right click on the results and when you say visualize tree, okay, we get the tree structure like this. Right. Now let me show you how to do this in the Colab environment using Python. So I'm going to create a new notebook and I'm going to ready to start. So let me name my notebook as INM517. Let me say, okay, ML machine learning using Python. Right. This is just a name I am giving to this. Right. Now, the first thing is we need iris data set. There are plenty of ways we can do. We can, get the data set as a file. We can open it up. But then, so since we are going to use machine learning in Python, there's a library called scikit-learn. So I'm going to show you the library first. So this is what you should prefer. So when I say, so we call scikit-learn, basically machine learning using Python. So this is the library that we are going to discuss in today's session. So, if you go to scikit-learn.org/table, so this is the documentation. This is the official page where we have everything. So you might already know in machine learning, we are handling different types of problem. But main problem that I'm trying to handle is classification. So you can click on classification, see the details. Okay, let me share with you the link. Right. Now I'm going to go inside the classification. We also call supervised learning. So if you go here, you will see that this is a very comprehensive library where you can see there are a lot of machine learning algorithms are already implemented. So we have to select, whatever the machine learning algorithm that you want to choose. Now, for example, you can see under the linear models, right? Under the linear models, hope you are familiar with linear regression. Logistic regression is what normally we will use under the classification. Similarly, support vector machine is another machine learning classifier that you can actually use. Then stochastic gradient descent, nearest neighbor. We already discussed nearest neighbor, so you can hear. Then naive Bayes and decision trees, right? So you can see we have already discussed ID3, C4.5, and there are other implementations as well. So you can read about this. For example, if you go to classification, so they will provide you a lot of information of how you might actually create a tree structure, right? So in scikit-learn, decision tree graphical representation looks similar to this, right? So you can actually find out more details on this. At the same time, if you go to classification, and if you want to know different types of decision tree algorithm, so all this information is also given here, right? So you can visit and read if you are interested on learning more. Right. So in our case, I'm going to use the same data sets. So scikit-learn, actually, you can also find data as well, right? So there are a lot of data is in it. You can actually use, for example, let me check. Scikit-learn data sets. So if you go to the page where data sets are, you can find there are lots of data that can be used. For example, what I'm going to use is the iris dataset, right? Iris dataset for classification. So you can click and then you can get more information about the iris dataset. So we are already familiar with, it says, okay, the dataset has 3 classes, samples per class is 50. That means each class you have 50 instances. The total will be 150. Dimensionally means number of features. There are 4 features and they are real and positive, right? So likewise, so you can read about how to use them. Okay, I think let's look at how we can work on this. So let me go back to my new notebook. So as I told you earlier, the very first one is loading the dataset. So I'm going to explain how we can load the dataset. So let me have a comment. I hope you remember this. Load iris dataset. Right. So the command for loading this is, we can say, from scikit-learn import datasets. So in that way, we can get the dataset, and we are getting these datasets from here. And then let me say it's iris. I'm going to get datasets dot load iris. So this is the method, and we'll get the data. right? And then if you say print iris, now you can see the details of the data set. Okay, let me run. Might take some time to set up the virtual environment and execute this. So you will see that when you say iris, this will contain all the information we need to work on the iris dataset. So you will see something like this. Okay, first let's try to understand what we have inside. So this is like a dictionary, you will see. I hope you remember. So in this particular case, you have keys and values, and the first one is the data. So in the data, you can see it's a NumPy array, and then this will have all the 150 data points. Then you will have something called target. Target means your class labels. In this particular case, we have 0, 1, and 2, which represents the 3 classes. Then if you go on, there are a lot of other information as well. For example, if you go here, so the target names, because in the target we have 0, 1, and 2. So the names are iris setosa, versicolor, and virginica. I think this would be enough for us to start with, right? So now that we have observed what we have inside, right? Now let's take our data and then the classes. So I'm going to get another coding window, right? So what we are going to do is we are going to assign data and the class, which is the target, right? So what we need to do is we have to get X, let me say, I'm going to get as iris data. So what happens here? I'm going to get the data part, right, from the data. You have seen that there was something called data, and that is my X. So similarly, Y, right, the Y I'm going to get that is as a target. So simply our labels. So if you do this, what happens? The X is our data part, Y is our target, right? So that's what we have done. So after we load the data set as iris, we separate out iris data part as X, the target as Y. Now that we have separated the data part as X and the targets as Y, let's observe what is in it. So I'm going to take the first 10 rows of X. What I mean to this is I'm going to say print X. Okay. So actually it is 0 to 10. What I mean by 0 to 10, if you remember, this is how you can specify the start and end. So ideally when you say 0 to 10, so it will take 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this will print the first 10 rows. Of course, if you have the 0, that is the start, you don't have to specify. So that's why we put it like this. So what this means, basically, we will select only the first 10 data points. So this is our X. We have 4 columns and then we have 10 records. So similar to the getting the first 10 rows of X, let's take the first 10 rows of Y. So simply we can say Y within the square bracket, we can say colon 10. And you can observe that. So this is the first class is 0, then 1, then 2. So we see the first 10 is from class 1. Now, similar to that, if you need to get the last 10 rows, you can use the same principle and get the last 10 rows of X and last 10 rows of Y. So I'm going to do it along in the same line. So let's the last 10 rows of X and Y. So the command is similar to the previous one. We can say print X, you will have minus 10 colon. So this is backward. Similar to that, we can say Y. We can say minus 10. So if you select last 10 rows of X and Y, here is how it look like. You will see you have the last 10 rows of X, then last 10 rows of Y. Right? Now let me show you how to visualize the data. Now remember visualization in this particular case, we need to use some plotting. So to plot, we have to use another library. This is called matplotlib. This is also another library we will use to visualize, especially when you want to visualize graphs. It's common we use. Actually, these are start with the MATLAB plotting. Same commands can be used here as well. So you can see how to draw various different types of plots with the plotting. You can go to examples and you can see you can actually develop various different types of graphs using Python codes. Right. So let me show you how to use this matplotlib library to develop a simple plotting for iris dataset. So let me start with a new code window. And first one is we need to import the plotting library. So we'll say matplotlib.pyplot as PLT. Right. So this is the library that we need to use. The next thing is we need to, now we have 4 columns, right? Remember our data set, we have 4 columns. We need to use, we have to select 2, columns at a time if you want to need a 2D plot, right? I hope you. So the command would be like plt.plot, and we can define whatever the values, X and Y values. So for example, we can say X values and the Y values, right? So ideally we need to select 2 columns, right? So I'm going to select one column. So I'm going to select, right, the third column from here. So what I mean by third column, so I will keep the same thing and I will just show you. So this is my X. If I just type X, you can see this is my X. And then if I want to select the third column, so this is how I use. So if I say colon, comma, now first colon will indicate that I'm going to select all the rows, and then whatever the value that I'm going to use next will represent the column. So if I put 0, you can observe here. So the first column we have 4.855 and so on. So you can see we'll select the values. Which one? I make mistakes? Yes, if you say X, yes, okay, sorry. We have 5.1, 4.9, 4.7, same, right? So if I say colon, comma, 0, so this will select the first column, 5.1, 4.9, and so on. Similarly, that is our first column. If I take the third column, that third column, we have 1.4, 1.4, 1.3, and so on. So this is how we are going to select colon, comma, 2. Why it is 2? Because we start with a 0, then 1, then 2. So if I do this, it start with 1.4, right? So you can say 1.4, 1.4, and so on. Right. So the plotting can be done by providing the values X and Y. So you can use two different values. So for example, I can say, let me take like this. I will say 1, 2, 3, 4. And then let me use some other values. Let me say 10, 20, 30, and 40. So simple plot would look like this. So you can give a vector and another vector here, right? So which will get some line plot like this. But if you want to like, uh, you know, represent as, let's say, just the points, you can put O. So this O, simple O will represent just the points only. So you can see now, I will have the points. So for example, if I want to use a red color, I can put R, which represent the red color. So this is how it look like. Right. So what I'm going to do, so the first part I'm going to take, right, the third column from the data set. So I'm going to say X colon comma 2. I hope you remember this. The second column I'm going to get, the second one I'm going to get the first column. First column means X colon comma 0. And then I'm going to represent everything from as circles, red circles. R is for red, O for circles. So therefore, when I plot it like this, so you should see something like this, right? And ideally, to complete this, I have to say plot plt.show. So if I do this properly, so it should look like this, right? So you will get the plotting. And if you right click on it, and if you say open image in a new tab, so in the new tab, you can see the graph clearly like this, right? Okay. So here is a code. So let's finish, and then I will explain again how to move from this point onwards. So if you carefully go through our visualization, you can see two clusters. We know that in our data set, we have 3 different classes. So you might guess that one class is easily separable from other 2 classes. But we cannot distinguish this because all our classes are in red color, right? So therefore, we have to use 3 different colors, right, to separate out the 3 classes. So let's do this now. Okay, now the task is we need to separate the data into 3 classes. And let me show you how to do this, right? So, so let me discuss how we can actually do this. So same command, what we are trying to do here is something like we are trying to separate the data. And right now we need to separate the data and we have to use different classes. Currently, what we have right now, I'm going to take a copy of this. I'm going to take a copy of this, right? And I'll put it here. I'm going to delete this one. Okay, so this is what we have, right? So here, remember, this 2 is third column. Remember, I told you 0 is the first column. So that's what we have selected. Now, the first part, this colon says that we are going to select all the data points. Okay, now we have a bit of a problem. Now, right now, we don't need all the data points. Why I'm saying this? Now we have three different classes. We have to separate out the classes with different colors. So what we are trying to do is, okay, we are going to separate the classes based on the values. So therefore, instead of this part, I'm going to select, right, first the class number 1, that is when y is 0. Similar to that, I will select, okay, y colon, and let's say equal 0. So if you do this, what will happen basically, in this particular case, it will select, right, data points where the y, the output class is 0. So it will select only a one particular class. Right. Now, similar to that, now let me run this. So if you run this, you will see that this will be only a one, data set, because it's just one class. So by changing this with different colors, now we can have another one. So we know the next class is 1. So I put 1 here. This is also 1. Let me use a different color. So instead of red, I will put gray. So now I have selected two classes. First class with red, the second class with gray. So let me run this so you can observe. So if you remember our previous graph, you might see that, okay, this will select the first class and the part of the second class. So that's what you observe here. So let me put another class, the third one, 3 different colors, right? Yes. So we know now what to do. So the class should be 2, right? The color should be, let me say, green. We use blue here. So now if you run this, okay, it look like this. So now we can see one class is easily separable from other two classes. The other two classes, there are some overlappings. Right. So let's implement this and then we'll continue. So let's improve the graph in this particular case. So I'm adding a title called Iris dataset with the font size. I'm setting to 20 points. Similar to that, let's label the two axes. So for that, I can use plt.x label. And then I can say what it is. Let's say this is petal length. Similarly, let's label the y-axis. And then we can clearly mention what are the labels. We call legend. We can provide the class labels. So let's say setosa, versicolor, virginica. And finally, you can say plt.show. So let me share the last couple of lines. And when I run it, here is how it looked like. So let me go to the image and this is how it looked like. So what we have discussed is how to put up the title, X label, Y label, and also the legend here. Now it's looked very professional. So when you draw the graph, simply we have to use the plot command and simply we have to provide the two vectors and simply this small string will indicate the color information and also the the symbol that you can use. Also, you can specify line type. So, so that's about the plot command. And then basically we also discuss how to put up a title, X label, Y label, also the legend. So that you can, complete a visualization using Matplotlib. Right. So what are our observation? As I told you earlier, so we can observe that the two classes in this particular case, you can observe that, okay, Setosa is easily separable from Versicolor and Virginica, and this is overlapping and this is clearly separated. Okay, so usually in machine learning, we do this as the first point, and we'll do, right? The next point is we need to develop the model. In machine learning, we discuss to evaluate how good our model, we have to separate the train and test data. So for that, we have to use the method. So let me explain that part. Right, now that we have X and Y, we need to separate them as train and test, or we have to use cross-validation. So let me, show you the simple separation of the data set as train and test. So to do that, we have to use scikit-learn dot model selection. Model selection. And then we have to use import train and test. We say split. Right. And how do you do that? Simply, we'll say X train, X test, Y train, Y test. Usually now you are automatically getting this part. Provide X and Y value. This is the data and then the target. And then we have to specify test set size, right? So remember, I told you like you can use different, sizes. In my case, I'm going to use 1/3 for train and then 2/3 for training, 1/3 for test, right? So that's why we specify test site size here. Then finally, I will also say random state. So this particular random state, so I'm going to say just, we can use, default, let's say 42. So the point that we are going to put the random state 42 is, in that way, we can have the same, split. So therefore, that means otherwise it will be a random and then we might get different results. To fix that one, we will use random state equals to 42. Right. Now that we have separated that, let's look at this, the size of this. So I'm going to say X train dot shape and then X dot shape, simply Y train dot shape and Y test shape. So let me run this. And if you run this, you can see it executed without any errors. And you can see the training data set. We have 100 data points and 4 columns. That is the train size, train shape, test shape. Then we have the test shape. That is, we have 50 data points with 4 columns. And Y, it's a vector. We have just 1 column. So we'll take 100 data points for train and then 50 for test. So in that way, now we are splitting data set as training and testing. Maybe I can put a comment here. Okay, so this is how we will split the data set as train. We'll take 2/3 and test. We'll do 1/3. Right. So once we select the train and test, next select the decision tree classifier. So I'm going to use from scikit-learn import tree. So, and then we'll say tree decision tree classifier, right? And then within this, I will specify random state. again, why I select the random state here also, I want to have the same tree as mine with yours as well. So we are fixing this random state. So let's put 0, right? And then we build the model. So we select the tree from this one, we are select the tree, and then we are build the model by providing the training, the X train and Y train. So now we are getting the classifier. So let me run this. So once you finish this one, what happens? Basically, we select the decision tree classifier, and then we use train and X train and Y train, and we'll train the model. Right. Next, let me display the model. In this particular case, let me discuss how to display the model. In this case, decision tree model. The command will be, we can use tree dot, there's a method called plot tree. And simply we can say CLF, and we can say plt.show. This should work. Yes, you should get something like this. This is the simplest tree possible for the decision tree. So when you are displaying, although you can see a tree structure, let me open up the tree structure. So you can see a tree structure, but you don't know like how the classification has been done, because the values are specified as x3, x2, x1, and so on. So what it means, this x3 means like you are selecting the third column, right? So basically you are going to select a different, fourth column. So you have various different features actually. So x3 in this particular case, meaning that your fourth attribute, right? And what it basically says, if your fourth attribute value is less than 0.8, you are going to go into this place. Right, this is not very informative. So let's improve this by providing information about, the details. First of all, you can provide things like this. Now, for example, here we have just put the CLF. So we can say feature names. We can provide feature names as iris dot feature names. Feature names. So when you run, you can observe now. And if you observe now, compared to previous one, right now we have x3. So here it says petal width. So instead of just x3, it is now identify the exact feature name. Right. Still, we don't know what our classes are. We have just some values only. So we can separate that one as well. So going back again, if you provide class names, it says class names. And if you say iris dot target names. So what we do is we provide the classes. Now let's run. Now you can see it will give you a class information. Let me show you separately. Now, if you look at carefully, so it says petal width and then there's a class. So you can see the first class is seto size here. The reason for this, it was clear even with the visualization we have observed. Class setosa can be easily separable compared to the other two classes. So you can see here as well, setosa is identified as the first part. Of course, you can make some coloring as well. So let me give you the full code. I'm going to say, okay, field true. And let me run this. Should be field true. So you can see the class information now as in colors. So this class is for setosa, easily separable from other two classes. You can see other two classes, we have purple and green. Right? So there is a lot of overlapping. So we have fill true. Similar to that, if you want to have round, 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 we can say true. Even we can say proportion. These are common ones we use. So when you run this now, you can see very nice graphs. So let me open up. Okay, this is what we have right now. So let me copy paste the code. Okay, try this. And if you able to see the tree structure like this, please raise your hands. If you want to increase the figure size, you can use this command figure. Basically, the size is in inches. 2012 normally considered as a large size. So let me run. So now you can clearly see compared to previously. You can open up, right? So looks now you can see, clearly see we have changed the figure size. You can clearly see how the classes are separated. So for example, starting with the root node, it says you check whether the petal width is less than or equal to 0.8. We have 100 samples and about 31% goes as a class setosa. Right? If it is not the case, then you check the petal width, right? And then you go on, right? So you can see how the classes are distributed. Right. I think now we have developed the visualization. Now let me show how to find the accuracies and also the error rates. Again, we have to identify. We have to write down everything separately. Right. Now, first of all, what we did so far, we separate our data set as train and test. We build the model and we visualize the model. So the model looks like this. Next one, we need to predict, right? So predictions. So if you remember, right, how do you predict? So we need to get predictions. And we'll get the classifier. This was done earlier and we'll say predict. Predict. And provide the test set. Simply what it means, right? I can print predictions. Simply, we use a model to predict for the test dataset. And here is how it look like. So remember, we take 2/3 as training, 1/3 for testing. So we have 50 elements here. These are predictions from our model. Then if you say print Y test, this will give you the actual labels. So this is predictions, this is actual. This is predictions. This is actual. Right? So if you carefully look at, most of the time you are getting the correct answers, but some places you see some errors. So here is one place you can see an error. Right? So likewise, you can check how many mistakes your model does. Predicting means given your data, it will predict. Right. Can you go through this and tell me what is the accuracy of our model? So this is we predict for X labels using X text, and this is actual. So what is the difference? And what is the accuracy rate? So now that one we make some predictions. So we apply the test set and we predict using our model. We can check with the actual. So we can observe the like there are two misclassifications. So 50 to 2, that is 96%. So to calculate the accuracy, we have to use from scikit-learn dot metrics, import accuracy score, and we can say print accuracy score, and we provide the actual, and then we have predictions. And if you run, you will get 96% accurate. So we have two mistakes for 50 data points, which means the accuracy is, yes, 96%. Right, now that we know the accuracy of this, let's see the confusion matrix. Confusion matrix means now we know that there are two misclassification. We need to identify how exactly the misclassification. So we can create a confusion matrix. So ideally what we do is we are going to use confusion matrix, and then we will have test and the predictions. So if you do this and if you run, you can observe that, okay, along the diagonal, we have a lot of, common ones along the diagonal. So you can notice the 19 instances. And then here we have 14 and 15. And then you have one instances, they are misclassifications. So two misclassifications you can observe. So it's between the other two classes, right? So that is confusion matrix. So this will give you a confusion matrix, and confusion matrix will give us the errors and how exactly errors are distributed with other classes. So the first one is clear separation. You can observe plus one is clear separation. The second and third, if you look at it, there are some misclassifications. That's why I said the first class is pure separable, whereas other two, there are some overlappings. So let me discuss how to get other measures like precision. So I'm going to say precision, recall, and F1 score. Right. So for that, we have to say for scale and matrices, classification report, print classification report, y-test predictions. Right. So let me run. And it looks like this. And remember here we have 0, 1, 2, which is I want the setosa versicolor, the names. I want to slightly modify the code. So I can say target names. We have setosa versicolor and virginica. And that we need to apply it here as well. So we have y-test predictions and then target names. So let me run this. Okay, now it looks good. So we can have the three classes, setosa, versicolor, and virginica, and we have all the other measurements, precision, recall, F1 score, and even the support. So in here, we have other measurements, precision, recall, F1 score. You can notice the setosa, it's perfect. One, precision is 1, recall is 1, F1 score is 1. But the other two, it's slightly different. Versicolor virginica, precision is about 0.9394. Recall 9394, and F1 is also 9394. Right? And overall accuracy is 0.96. Right. Now that we have evaluate, what do you mean by evaluation? So we got start with the data set, separate X and Y, and we evaluate. We observe how good our model in future. Right. Next is building the final model. Remember that we separate the data as training and testing to evaluate, to know how good our model for the new data. But of course, right, you can actually utilize all the data for the final model. So the final model, the decision tree model, should be something like this. Let me say CLF, classifier, classifier dot fit, have except one. So let me run this. So it's not specified, it should be CLF. And if you want to see the outcome, you can use the same, but that will be our final tree. So you can observe that we build the final model, and this is what we are going to use. And we also observed right. So now we have observed building the process with Python. And let's say we want to create or we want to predict just a single row, right? So you can specify row. Let me say, I'm going to say a row. And I will have some values. Let's say some measurements. I'm going to put some arbitrary values. And then we can simply predict it, right? And simply we can say, okay, predict row. So if you do that, you can notice that this will be 0. So what do you mean by this? 0 means it's Setosa, right? Our first class. So that is Setosa. So if you want to check what 0 here is, we can get that information. So ideally we have to get this into a, let's say, y hat predicted value. Let me say predict, and then we'll say y hat 0. So it says predicted 0, but here 0 means a class. Actually, we'll say use if. I'm going to use the latest Python version. Okay. So will be the same. Yes. But then again, this is, if you're using Iris, we'll say target names. And within that, we have to say like this. So you can observe. It says predicted class would be Setosa. Of course, you can actually change the values and observe what might happen. depending on the values, you might get different results. So I'm actually sharing you the code for this. We'll say set awesome. Uh, Actually, there are like application we can build around like this. You can see we have written a code. We build the model and then we are trying to predict it. I showed you how simple one can be something like this. You can provide the values and then you can change. But if you want to try it out some simple applications like Gradio app is something that we can use. Just copy paste this code. I will put it in the chat where we can build, where you can build a simple application. So in my case, I have put the code and I have run it. So this is how it looked like. So now I had to provide the values 5.1, 3.5, 1.4, and 0.2. When you click submit, and you will see that you are getting the outcome as it was. So it will be a now complete application, right? This is how we can actually build and implement the systems, right, in Python. So going from the beginning, what we have done so far. So in today's session, what I have explained is how we can have machine learning application in Python. The main reason for learning or implementing Python is when you want to deploy, use the Python is the language now we use. So in this particular case, I have actually used a very simple dataset, iris dataset from the scikit-learn Python machine learning library itself to explain this. So we got the iris dataset and we learn how separate X and Y. The X is the data part and Y is the target. And then then we learn how to visualize this, like drawing nice graph where we can visually see how easy or difficult the three classes. And then to evaluate, to see how our good model is, we separate the data as train and test. So we got 2/3 of data as train and 1/3 for testing. And we build the tree structure and we displayed the model as a tree structure. And then we make the predictions and calculate the accuracies. So in this particular case, we have observed that our model is 96% accurate. Then we look at the confusion metrics to identify how the misclassifications happen, the off-diagonal elements. Then also we discuss how to get other measures like precision, recall, and F1 score. And finally, to build our final model, we use all the data points what we have, X and Y, and this was our final model. Right, after finishing that, we have discussed, given some data points, how do you find the predicted class label? So in this particular case, by changing these values, you can get different results, right? And then final part, I also gave you the code for Gradio app, which is nowadays quite common that you showcase your applications. So I have like 4 input boxes and 1 output text box. So given the data and when you submit, you will observe that. So it will predict it as a set or sum. So I think you understood whole process of, using machine learning in Python, especially in classification. Okay, so that's all what we have for today.